Welcome back to the course Introduction to Green Process Engineering. Today we will focus on the transition path of the agri-food system. First, we will have a look on the main challenges, and then we move on to the most relevant technologies. The agri-food system is facing a multitude of challenges: sustainability, efficiency, and the ability to meet global feed requirements being the most pressing ones. Rising temperatures, altered precipitation patterns, and increased frequency of extreme weather events affect agricultural productivity and food security globally. Our food system consumes large amounts of natural resources and results in biodiversity loss and negative health impacts due to both under- and overnutrition. The Farm-to-Fork strategy, which is at the heart of the Green Deal of the European Union, aims at sustainable food production, processing, and consumption, accompanied with measures to prevent or minimize food losses and waste. Thereby, it addresses climate-related impacts while fulfilling the food needs of a growing population. Hence, resilient agricultural practices and crop varieties capable of withstanding changing climate conditions need to be developed. So, what are measures to secure food supply within these boundaries? The transition path for the agri-food system is organized along the following building blocks: digitalization and technology adoption, sustainable production practices, circular economy and waste management, cooperative and collaborative models, policy and governance frameworks, consumer engagement and education, research and innovation in agri-food system, and economic viability and investment. Behind these 8 building blocks, there are 46 carefully structured measures, including environmental, social, and economic impacts. Today, we will focus on the first 2 topics. Digitalization in agriculture deals with the practice of using advanced technological solutions such as sensors, robotics, and data analysis for improving the ecological and economical viability of agricultural operations. Let's have a closer look at that. The use of technologies such as the Internet of Things, blockchain, and big data analytics form the backbone of digital transformation in the agri-food sector. These technologies facilitate real-time information sharing and thereby improve supply chain coordination. To give an example, Internet of Things devices can monitor crop conditions and environmental data, providing farmers with actionable insights that allow for timely interventions, thereby optimizing the resource use. Further, the integration of big data analytics allows for improved decision-making capabilities. Analytics can evaluate vast data sets from various sources, including production methods, market trends, and consumer behaviors, to identify efficiencies and address potential challenges. This leads to data-driven decisions, which can be implemented timely in the running production process. The most prominent example for sustainable production practices is organic farming, which includes measures such as crop rotation. By alternating different crops in a specific sequence on the same plot of land, farmers can disrupt pest cycles and manage soil nutrients effectively. Thereby, the need for chemical fertilizers and pesticides is reduced, leading to improved soil quality, higher agricultural productivity, and resilience against climate changes. Organic farming also does not use agrochemicals or genetically modified organisms for production. Further, animal husbandry, which refers to the integration of animals into a farm, helps to create a closed or semi-closed system where energy and nutrients are recycled. Animals can convert non-edible biomass, such as grass, straw, or kitchen waste, into food while increasing soil fertility with their manure. The use of biofertilizers, green leaf manure, and vermicompost, and biological management is included in organic farming. By these measures, agriculture develops towards sustainability. Besides organic farming, there are also technologies such as CRISPR and genetic engineering to enhance the genetic traits of aquacultural species. Improving their growth rates and resistance to disease are vital for sustainable production. As an example, the so-called biofloc technology uses microbial cultures to treat waste produced in aquaculture. Thereby, the feed utilization is highly increased as the produced waste is also converted into a supplemental protein source for fish. This method creates a more closed-loop system within aquaculture, reducing environmental impacts and resource consumption. Advanced aquaculture feeding system should also be named in this context. As you can already see, there are many factors related to aquatic systems. Hence, let's have a look at one system in particular, the so-called aquaponics system. Aquaponics systems combine aquaculture, meaning raising fish, with hydroponics, meaning growing plants without soil. These two applications function in a symbiotic environment that minimizes resource use and waste. Here you see how such a system works. The fish waste provides nutrients for the plants, while the plants help to filter and clean the water for the fish. This closed-loop system minimizes water usage and eliminates the need for synthetic fertilizers. Aquaponic systems are of particular interest in urban regions. With that, I'm already at the end of today's presentation, where we focused on the transition of the agri-food system, which is at the heart of the European Green Deal. The transition path includes a multifaceted approach that ranges from social acceptance to research and innovation and technologies. A large topic is digitalization and technology adoption, which we focused on in more detail. We also discussed sustainable production practices, where organic farming is by far the most prominent one, but also aquaponics was shown. It is clear that the content of this video offers just a glimpse of the transition in the agri-food sector. I hope I was able to awaken your interest, and we will meet again in the next section of the course. Thanks for watching and goodbye.